Hi and good afternoon, everyone. So welcome to our Q&A summer course. So students, let me introduce myself first. So hi students, I am Sunit Kumar, your mathematics teacher. So we were doing in the previous class, we were doing polynomials and we were doing relationship between the coefficients and the zeros of a polynomial. So let us continue the class. So as I said, students, we'll continue with this topic polynomials in today's class. And today we'll be doing lecture 5 of this topic of this chapter. Prerequisite for today's class is, student, you should know about algebraic expression. You should know about the degree of a polynomial, the types of polynomial as per the degree of a polynomial, the value of a polynomial at a particular value of a variable, and how to find the zero of a polynomial, right? And the outline for today's class is, student, we'll do questions based on relationship between zeros and coefficients of a polynomial, which we had done in the previous class as well. And we'll also find zeros of a quadratic polynomial. So let us quickly revise the identities which we were doing in the previous class at the last of the class. So alpha square plus beta square, if we want to write this in the form of alpha plus beta and alpha beta, so alpha square plus beta square can be converted into alpha plus beta whole square minus of twice of alpha beta. So this is the first identity which is very useful to us. Second is alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. So this is second identity which is quite useful to us, where we have to find alpha minus beta. We use this second identity, right? The third identity is alpha cube plus beta cube is alpha plus beta whole cube minus 3 times alpha beta into alpha plus beta. We had also seen how to derive these identities. Okay, so we'll do that. We'll revise that as well. So alpha 4 plus beta 4 can be written as alpha square plus beta square whole square minus twice of alpha beta whole square. So let us one by one quickly derive all of this. So we know that alpha plus beta whole square by identity, it can be written as alpha square plus beta square plus 2 alpha beta. Now, since we have to find the value of alpha square plus beta square here, we'll take 2 alpha beta on the other side. So we will get alpha square plus beta square is alpha plus beta whole square minus of 2 alpha beta, which is our first identity. Is it clear? Raghavi, Ragul, and Devi Maya? Yep. So now what we'll do, students, the second identity, if you see, the second identity is alpha minus beta whole square. So we know that alpha minus beta whole square is equal to alpha square plus beta square minus 2 alpha beta. And the value of alpha square plus beta square from the first identity can be written as alpha plus beta whole square minus 2 alpha beta and again minus 2 alpha beta. So this is alpha plus beta whole square minus times 4 alpha beta, right? So this is your second identity. Now the third identity, students, we also saw this third identity where, if we expand alpha plus beta whole cube, this is equal to alpha cube plus beta cube plus 3 alpha beta times alpha plus beta. Now, if we have to find the value of alpha cube plus beta cube, bring this 3 alpha beta, alpha plus beta, this term to the left. So we will get alpha cube plus of beta cube is equal to alpha plus beta whole cube minus 3 alpha beta, alpha plus beta. Is it clear? The third identity? Okay. So now the fourth identity, if you see, alpha 4 plus beta 4, this is quite similar to the first identity, right? Only difference is that replace alpha square by alpha 4 and beta square by beta 4. So wherever you have alpha, it will get replaced by alpha square, beta square, and here also alpha square, beta square. So if you do alpha 4 plus beta 4, this is nothing but instead of alpha, we'll write alpha square plus beta square whole square minus 2 times alpha square beta square. So if you take square as common, this will be minus of 2 times alpha beta whole square. Clear, students? Is it clear to everyone? Okay. So let's start the practice if it is clear to everyone. So here in this question, students, if alpha and beta are the zeros of the quadratic polynomial fx is equal to ax square plus bx plus c. So if we have a quadratic polynomial of the form ax square plus bx plus c, which is the general form of quadratic polynomial, then calculate alpha square plus beta square. So how do you calculate alpha square plus beta square? We write this in the form alpha plus beta whole square minus 2 alpha beta. And we know that from the expressions, the relation between sum of the zeros and product of the zeros with the coefficients of the polynomial, alpha plus beta is minus b by a and alpha into beta is c over a, right? So we have these two relationships which we already know, sum of the roots and product of the roots. Use it in this expression. So alpha plus beta whole square is minus b by a whole square minus 2 times alpha beta, that is 2 times c by a. So this will become b square by a square minus 2c by a. If you take LCM as a square, the first term remains as it is, but the second term you will have to multiply both numerator and denominator by a. So this will become b square minus 2ac over a square. So alpha square plus beta square in terms of a, b and c, this is what you are going to get the answer as b square minus 2ac by a square. Is it clear to everyone what we have to do in these kind of questions? You have to replace alpha square plus beta square. You have to write it in simplified form in terms of a, b and c using the two relationships which we already know, that the sum of the zeros alpha plus beta is minus b by a and the product of the zeros alpha into beta is equal to c by a. Using these two identities, we will replace in the identities which we have seen and get the final simplified answer. Is it clear? Okay, so let's do the questions now. So the next question I'll give you time to solve it. Again, the polynomial remains the same, ax square plus bx plus c. You have to calculate alpha upon beta plus beta upon alpha. Quickly, please calculate this and let me know the answer. Alpha by beta plus beta by alpha. Try to first simplify this. Once you have simplified it, you will be able to replace it by the coefficients using the relationships which we already know, that sum of the zeros alpha plus beta is minus b by a, product of the zeros alpha into beta is c by a. We'll use these two identities, these two relationships. How do you simplify this? So the LCM of this is alpha beta. So you will have, because there is no alpha in the first term, you will have alpha into alpha, that is alpha square, and then beta into beta is beta square, right? Generally what we do, we take a cross multiplication here. So alpha into beta and then alpha into alpha plus beta into beta, that is alpha square plus beta square. Now this can be written as by identity alpha plus beta whole square minus of 2 alpha beta over alpha beta, right? Now replace the values of alpha plus beta and alpha beta using the known relationships. So this will be equal to alpha plus beta whole square, means minus b by a whole square, minus 2 times alpha beta, 2 times c by a, divided by alpha beta, that is c by a. Okay. So this will be equal to b square over a square minus 2c by a over c by a. Now take LCM in the numerator as a square. You will have b square minus 2ac over c by a, right? Now what you will do, you will cancel these terms. You will get a single a here, and this c goes and multiplies with this denominator. So the answer, final expression will be b square minus 2ac over ac. This is your final expression. Yes, Raghavi, you are correct. B square minus 2ac over ac. So Raghavi, you have missed c in the second term. Is this clear to everyone? Have you understood this concept? Ragul, Jovin, Alan and Devi Maya, have you guys also understood the concept? Okay, good. Let's go to the next question now. I hope you have noted this down. Let's go to next question, students. Now, using the same polynomial, you have to write alpha cube plus beta cube in terms of a, b, and c. Please do it. You will be using the identity alpha cube plus beta cube is alpha plus beta whole cube minus 3 times alpha beta into alpha plus beta. And you will use the two known relation alpha plus beta is minus b by a and alpha beta is equal to c by a. These are the two known relationships which you will use here. So wherever you have alpha plus beta, use minus b by a there. Wherever you have alpha beta, use c by a there. And then solve it and get me the answer, final answer. I hope everyone is attempting the question. So in this question, what we do, if we have to put alpha plus beta whole cube, so we'll replace it by minus b by a whole cube minus 3 alpha beta. So this is negative of 3 times alpha beta is c by a and alpha plus beta is minus b by a. So we will have negative of b cube over a cube and then positive 3bc over a square. If you take the LCM here, LCM is going to be a cube and then we have minus of b cube plus of 3abc, right? So you can arrange this as 3abc minus b cube over a cube. This is your answer. the value of alpha cube plus beta cube in terms of a, b, and c, the coefficients of the quadratic polynomial here, will be 3abc minus b cube over a cube. Clear, students? Have you all understood this? These are very important questions, right? Instead of ax square plus bx plus c, you may get numbers also. So this is tricky because it is in terms of a, b, and c. Generic, the general quadratic polynomial. But you may have specific ones as well, like 3x square plus 2x plus 4. So you will replace a, b, and c by 3, 2, and 4 there. So those will be numbers which will be easier to solve. But you have to practice this, because if you practice this, you can do it with numbers easily. Let's move to the next one now. Similar question, you have to do it 1 by alpha cube plus 1 by beta cube. So you will first find the LCM of the denominator and then solve it. So when you simplify this, you will get beta cube plus alpha cube divided by alpha cube into beta cube. So this can be written as alpha plus beta whole cube minus 3 alpha plus beta divided by alpha beta whole cube. Now simply replace alpha plus beta by minus b by a and alpha beta by c by a. Okay? Do this and simplify it. Tell me the answer if you have simplified it. Yes, Raghavi, you are correct. So alpha plus beta whole cube can be written as minus b by a whole cube. Minus 3 alpha beta means 3 times c by a into alpha plus beta, that is minus b by a. Alpha beta whole cube is c by a whole cube. So this is minus b cube by a cube plus of 3bc by a square divided by c cube by a cube. So you will get minus, so if you have LCM as a cube, minus b cube plus 3abc over c cube by a cube. You cancel the a cube terms here. So what you will get is 3abc minus b cube over c cube. Is it clear? Others, is it clear? Ragul and Devi Maya, Jovin and Alan. Are you able to understand? So
Yes,
please
sir.
please be involved in the class. So try to solve it, right? If you attempt it, then only that inhibition will go, and you will be able to solve it during the exam also. Even if you are able to understand, do it, try it, and then see whether you are able to get the final answer or not. Because finding the final answer would be more important. Okay. Okay, so let's move to the next one now. I hope everyone has noted this down. You have to find the value of alpha square upon beta plus beta square upon alpha. So you have to find the value of alpha square by beta plus beta square by alpha. If you simplify this, if the LCM is alpha beta, you will have alpha cube plus beta cube in the numerator, right? And then alpha plus beta minus b by a, and alpha beta is equal to c by a. You are going to use these two. So this can be written as alpha plus beta whole cube minus 3 alpha plus beta divided by alpha beta. So this is minus b by a whole cube minus 3 times c by a into minus b by a divided by c by a. So which is minus b cube plus 3abc by a cube, as we have been doing in the previous questions, divided by c by a. So 1 by a, 1a gets cancelled. So you have 3abc minus b cube upon a square c. Yes, Raghavi, it is correct for you. Okay. So the value of alpha cube plus beta cube, we have already calculated 3abc minus b cube over a square by over a cube. So you can use that also directly and get the answer if you remember that relationship. Clear? Let's move to the next one now. Has everyone noted this down? Has every one of you noted this down? Okay. Next is you have to find the value of alpha 4 plus beta 4. If you remember the identity, it was alpha square plus beta square whole square minus 2 times alpha beta whole square. Okay. Separately, find the value of alpha square plus beta square, that is alpha plus beta whole square minus 2 alpha beta. Put the values and find it out. So we have two relation, alpha plus beta is minus b by a and alpha beta is equal to c by a. Use these relations here. You will use these relations here, and once you have got this value, you will put it here, and then you will simplify and find the answer, final answer. So if you put the values, so we have minus b by a whole square minus 2c by a. So this is b square minus 2ac over a square. Use it in this relation. So we have alpha square plus beta square whole square means b square minus 2ac by a square whole square of this minus 2 times c by a so this is minus 2 times c by a whole square. So this is b4, or you can write it in this form only. So b4 plus 4a square c square minus 4a b square c minus 2c square. So this is 2c square over a square, and here we have a to the power 4. Right? Now if we take your LCM as a4, so we will have b4 plus 4a square c square minus 4ab square c, and then we have negative of 2a square c square. So this is going to give you b4 So if you solve this 4a square c square minus 2a square c square, you will get 2a square c square minus 4ab square c over a4. Is it clear? Everyone, is it clear to everyone? Okay. Please note this down. So we'll do one more question similar to this. Okay. And then we'll move to the next kind of questions. Now in this question, you have to again find the value. Please try it on your own once. Alpha square by beta square plus beta square by alpha square. So if you find the LCM here, this is alpha square beta square.
Sir, can you 1 minute show the previous slide?
Yeah, please.
Yes, sir.
Okay. So here when we find the LCM as alpha square beta square, we will have alpha 4 plus beta 4 here, right? So the value of alpha 4 plus beta 4 we have already calculated. We can use it here, right, from the previous question, and replace alpha square beta square by c square by a square. So alpha 4 plus beta 4, we had b4 plus 2a square c square, b4 plus 2a square c square minus of 4ab square c divided by, we had a4. This is what we had got in the previous question for alpha 4 plus beta 4. We are directly using the result here. So here when you cancel this, you will get a square. So this is b4 plus 2a square c square minus 4ab square c divided by a square c square. This is your answer. Is it clear? So I have not done this alpha 4 plus
Yes,
beta
sir.
4 separately here. This I have directly used this result from the previous question. So if you see this previous question, this was the result which we got, right? Finally. So we have used this result directly here. Did you understand, students? Everyone has understood this? Yes, Raghavi, it is correct. Very good. So let's move to the next one now. So in this question, what has been asked, that if alpha and beta are the zeros of the quadratic polynomial x square minus 5x plus k, this is the quadratic polynomial, such that alpha minus beta is equal to 1, we have to find the value of k. So what is given in the question is alpha minus beta is equal to 1, right? What other relationships which we already know is alpha plus beta is minus b by a. So here in this quadratic polynomial, this will be negative of negative 5 because b is negative 5 over 1. So alpha plus beta is equal to 5. Alpha beta will be c by a, which is k by 1, that is k. So we know the value of alpha minus beta, alpha plus beta, alpha beta. We have to find the value of k. Yes, Raghavi, it is 6. Good. So here, students, what we do is we know that See, either we solve this pair of linear equation, get the value of alpha and beta. Another way is that we we can write this as alpha minus beta whole square is alpha plus beta whole square minus 4 alpha beta. So this was the identity which we used, the second identity in the first slide which we are doing today. So alpha minus beta is 1, 1 square is equal to alpha plus beta is 5, 5 square minus 4 times alpha beta is k. So this will be 1 is equal to 25 minus 4k, or 4k is 25 minus 1, that is 24. K is 24 over 4, which is equal to 6. Is this clear to everyone? Ragul and Jovin and Alan, is it clear to you guys? Devi Maya?
Yes,
Okay,
sir.
good, good. Please note this down. Has everyone noted this down? Okay. So now please attempt this question. Do it on your own. Find the value of k. If alpha and beta are the zeros of quadratic polynomial kx square plus 4x plus 4, such that alpha square plus beta square is given as 24, find the value of k. Use the identities which we have done and the relationship of alpha plus beta and alpha beta with the coefficients. So students, this is the last question for the day. And after this, we'll practice on the platform. Okay. So you will log in on the platform and I'll tell you the topic from which you need to practice. There will be two values of k, Ragul. Just check it. So here alpha square plus beta square is 24, which we can say that alpha plus beta whole square minus 2 alpha beta, right, is equal to 24. We also know that alpha plus beta is minus b by a minus 4 by k, and alpha beta is c by a, that is again 4 by k, right? Put it here. So we'll have minus 4 by k whole square minus 2 times 4 by k is 24. So this is 16 by k square minus 8 by k is 24. So now take LCM as k square. So we'll have 16 minus 8k is 24. Now cross multiply this. We will get 16 minus 8k is 24k square. Now you can take 8 common. So this is 2 minus k is equal to 24k square. You can cancel this. We'll get 3. So bring everything on one side. So 3k plus k minus 2 is equal to 0. Now what we'll do, we'll factorize this. So 3 into minus 2 is 6. So we will do 3k square plus 3k minus 2k minus 2 is 0. Take 3k as common, k plus 1, minus 2 as common, k plus 1 is 0. So this is 3k minus 2 into k plus 1 is 0. So this will give you k is equal to minus 1 or k is equal to 2 by 3. So these are the two values of k. Yes, Raghavi, it is correct. K is equal to minus 1 and k is equal to 2 by 3. Is it clear to everyone? Has everyone understood this question? So here you have got a quadratic equation. So what we'll do, we will factorize this quadratic polynomial into two factors and then equate it to 0 separately, because the product of two terms, if it is 0, either of them will be 0. So 3k minus 2 into k plus 1 is equal to 0. That means either 3k minus 2 will be 0 or k plus 1 will be equal to 0. So we have separately equated it to 0. So first term, when you equate 3k minus 2, when you equate 3k minus 2 to 0, you will get k is equal to 2 by 3. And when you equate k plus 1 equal to 0, you will get k is equal to minus 1. So these are the two values of k which you get after solving this quadratic polynomial, quadratic equation. Is it clear to everyone? Has everyone understood the concept here?
Yes, sir. Clear.